Thank you, Dr. Barrett. My project focuses on visceral leishmaniasis, a neglected tropical disease in which Leishmania donovani parasites infect the liver, the spleen, so they target the visceral organs, which is why we call it visceral leishmaniasis. Visceral leishmaniasis is the second most lethal parasitic infection after malaria, and in fact, it's 100% fatal in the absence of treatment. Unfortunately, there is currently no human vaccine available. So how do we go about designing a vaccine? There are three main approaches to develop a vaccine. The first is to use part of the microbe, DNA or protein, for example, to vaccinate. The second approach uses killed microorganisms. And the third is to use what we call naturally attenuated vaccines. Killed vaccines have been tried against leishmaniasis, but they were unsuccessful. And the problem with DNA or protein vaccines is that they can be expensive to produce, something that's not really suitable for a neglected tropical disease, which is why we decided to focus on a naturally attenuated approach. So naturally attenuated vaccines take advantage of related microorganisms that cause mild disease to vaccinate against severe disease. And this is what was done to target smallpox. Dr. Jenner noticed that people who developed mild cowpox were protected against severe smallpox. And this was a very successful approach. In fact, it led to the eradication of smallpox worldwide. So to use this for leishmaniasis, we need to find a naturally attenuated Leishmania strain. And we found this in Sri Lanka. In Sri Lanka, Leishmania donovani parasites stay in the skin instead of targeting the visceral organs, and the infections can heal on their own. So this represents a naturally attenuated parasite. So we isolated parasites from this patient here and used it in mice to vaccinate. This was very successful. We found that mice that were vaccinated had almost 10 times less parasites in their liver than unvaccinated mice. So this is protective. But a vaccine doesn't just need to protect. It also needs to be safe. And remember, we're vaccinating with live organisms. So you don't want them to stay for too long. And this is shown in the left panel. As you can see, by 8 weeks after vaccination, all of the parasites are gone from the site of vaccination. But you also don't want them to spread to any organs. And this is on the right panel. The vaccine parasites did not spread to the visceral organs, so this was safe in our mouse model. So overall, we isolated a naturally attenuated Leishmania donovani strain from Sri Lanka and found that this protects against visceral leishmaniasis in a mouse model. Overall, this research indicates that naturally attenuated parasites and their use as vaccines are a suitable option to target visceral leishmaniasis. But this is in a mouse model. Before we can reach the human population, of course, safety concerns still do need to be addressed. Thank you.
I'm wondering what you learned together as a group from this event, what you've learned about presenting your research and how working together was helpful.
I think in addition to the whole interaction between researchers and public, the other advantage from this interaction is us interacting with each other. We did a lot of practices together, so we got peer review feedback from people from other disciplines on how other researchers have different approaches to target different issues. And in the end, we're all trying to change the world in our own different ways, how that fits together.